So here we have a problem that we're going to represent using a linear model or a linear function in order to answer some questions about it. So first, when you have such problems, you need to identify the initial value. So that is the value that isn't changing, and that is the 19,000. So that's our initial value or our y-intercept. Then we need to identify our rate of change. Now the rate of change is the number that goes up or down per something else happening. So this says it decreases by 2,500 for each year. So that's the same as saying per year. So that's our rate of change. So we can set up a linear equation and remember that that is y equals mx plus b, where m is our rate of change and b is our initial value or y-intercept. For this particular scenario though, they want us to use v for dollars and they want us to use t for number of years. So our equation will be v equals negative 2,500 because my rate is decreasing, therefore it's going down, so it's negative, t plus 19,000. So 19,000 is my initial value and negative 2,500 is my slope or my rate of change. So here are some questions about the scenario, and the first one asks, what is the value of the car when t equals 0, and to show it on the graph. So let's have a look at our graph. So when t equals 0, we're talking about our y-intercept, or in this case v. And that is our initial value, which is 19,000, which goes right here. So when t equals 0, the value of the car is 19,000. You can also verify that by plugging 0 into the equation. So it's negative 2,500 times 0 plus 19,000. And if you plug the 0 in here, you're going to get $19,000, which we got anyway. There are a few other different questions that you could be asked. This one asks, what is the rate of change? Now we've already seen the rate of change. The rate of change is negative 2,500. And how it relates v to t is that v is decreasing by negative 2,500 t per year after an initial 19,000. Now, when you have a look at it, we know it's negative because it's decreasing. It's decreasing in value every year. So our slope should go down this way when we graph it. So it is negative. You could also be asked to find various values of v for different amounts of t. We can find them on the graph and we can find them algebraically. Let's do one algebraically first. So we know that v equals negative 2,500 t plus 19,000. So let's substitute t equals 1 into that equation. And what I mean by that is I'm going to put t equals 1 instead of t and then calculate. So that equals negative 2,500 plus 19,000, or if you like, 19,000 minus 2,500, which is $16,500. So after 1 year, or when t equals 1, v, or the value, is 16,500. Let's go have a look at that on our graph. So when t equals 1, we're here, and we've got to go up to 16,500, which is halfway in there. Or using our rate of change, we have gone down from 19, down 2.5, and across 1. So now let's look at t equals 2. Again, we're going to substitute and multiply by 2 in place of t and add 19,000, which equals $14,000. So after 2 years, or when t equals 2, the value will be $14,000. And let's look at that on our graph. So at t equals 2 down here, we can go up and find 14,000 and plot that on our graph. Or we can use slope and go down 2,500 and across 1 using our rise and our run. Lastly, we're going to work out when t equals 7, so after 7 years, what the value of the car is. So we just plug that into the equation where t is, and that equals $1,500. And on our graph, that's all the way down here. Now we can connect them together and make a straight line graph. And there you have your graph right there. So now from this scenario here, you have written its equation, displayed its graph, determined a set of points to verify your slope and your line so that it's correct instead of just using slope and initial value, and answered a couple of questions about it. So overall, you have now shown that you can model a real-life scenario like this one by using linear equations.